Hello everyone and welcome to the lecture on Amazon SageMaker Ground Truth. So this lecture will contain all these topics. What is Amazon SageMaker Ground Truth? Task types, automated data labeling, pre-built or custom tools for labeling tasks, workforce choice for data labeling, creating a labeling job, classify image type jobs. So the first topic is what is Amazon SageMaker Ground Truth? To train a machine learning model, you need a lot of good data. Ground truth helps you build high quality, labeled datasets specifically for training your models. You have choices on who does the work. You can use workers from Amazon Mechanical Turk, a vendor company that you pick, or your own internal private team. It does not just use people, it works by using these human workers along with machine learning to help you create your labeled dataset. Once you have the labeled dataset output from ground truth, you can use it to train your own custom models or Amazon SageMaker AI model. Second topic is task types. So depending on your machine learning application, you can choose from one of the ground truth built-in task types to have workers generate specific types of labels for your data. You can also build a custom labeling workflow to provide your own UI and tools to workers labeling your data. Third topic is automated data labeling. In order to automate labeling your training dataset, you can optionally use automated data labeling, a ground truth process that uses machine learning to decide which data needs to be labeled by humans. Automated data labeling may reduce the labeling time and manual effort that is required. Fourth topic is pre-built or custom tools for labeling tasks. You can use either pre-built or custom tools to assign the labeling tasks for your training dataset. A labeling UI template is a web page that ground truth uses to present tasks and instructions to your workers. The SageMaker AI console provides built-in templates for labeling data. You can use these templates to get started, or you can build your own tasks and instructions by using the HTML 2.0 components. Fifth topic is workforce choice for data labeling. So use the workforce of your choice to label your dataset. So you can choose your workforce from first option is Amazon Mechanical Turk workforce of over 500,000 independent contractors worldwide. Second option is a private workforce that you create from your employees or contractors for handling data within your organization. Third option is a vendor company that you can find in the AWS marketplace that specializes in data labeling services. Sixth topic is how to create a labeling job. So you can open SageMaker AI console. Then you can choose the labeling jobs from the left navigation menu and you can just click on create labeling job. Then you will configure the job overview section and you will provide the job name. Then you will provide the label attribute name. So unique name for the job, label attribute name. So default is unchecked. Then input data setup. So you will select the S3 input location, which is pointing to your images path. Then where should be the S3 output location path for your output data type. So you can select the default, let's say image, and you have to provide a role. So default is Amazon SageMaker full access policy. Then you have to give the task type. Let's say you have selected image in the task category field and task selection bounding box. So I'll cover there like 6 different task types. Then choose next, and finally that's how you create a labeling job. Next, classify image type jobs. So there are different type of image classification jobs type. So first one is, we call this classify image objects using a bounding box. So this is the first type, and this task type is used to identify the location and category of specific objects within an image. It combines object detection, finding where the object is, with classification, identifying what the object is. So workers are presented with an image and a list of predefined categories. For example, let's say car, pedestrian, traffic light. They must draw a rectangular box. So we call this a bounding box around each object of interest to enclose it completely. This process localizes the object by defining its pixel coordinates within the image. The resulting data is typically used to train computer vision models for the object detection systems such as those used in autonomous vehicles. Next type is identify image contents using semantic segmentation. So this is a high precision labeling task where every pixel in an image is assigned to a specific class or category. Unlike bounding boxes which provide a rough area, semantic segmentation provides the exact shape and boundary of an object. So basically there you have a square here, but you have to be very you'll use a tool to identify the pixels. So here workers use a brush or a polygon tool to paint or mask specific parts of an image with a color corresponding to a label. For example, blue for let's say sky and green for grass. So that in the same image, let's say there is sky as well as grass. So you have to identify that, okay, this is sky. You will create a polygon around sky, and for grass underneath that, you will make one more and you say give it a color, like you will have to choose a blue or green, and there can be different colors depending on how many objects are there. So the output is a pixel level mask where the background and the foreground objects are clearly separated by their exact contours. This is essential for applications requiring precise understanding of scene geometry, such as medical imaging analysis or satellite imagery processing. Next type is auto segmentation tool. This is an assistive tool built into your worker UI for semantic segmentation tasks. It is designed to speed up the laborious process of pixel level labeling by automating the creation of masks. So this will just help the previous task type, which is the semantic segmentation. So instead of manually drawing a complex polygon or brushing over an object pixel by pixel, the worker simply draws 4 points defining the extreme edges of the object, for example, top, bottom, left and right. The tool then uses a machine learning algorithm. Specifically, the name of the algorithm is Deep Extreme Cut for Dexter algorithm, to automatically generate a tight fitting mask around the object. The worker can then refine this mask if necessary, significantly reducing the time and fatigue associated with manual segmentation. So next type of image classification is single label. Create an image classification job, single label. So this is the standard categorization task where an entire image is assigned to exactly one category from a predefined set. It is mutually exclusive, meaning an image cannot belong to more than one class. Workers are shown an image and asked to select the single best description from a list of radio buttons. For example, is this image a dog, cat or a bird? If the worker selects dog, they cannot also select cat. This is used for sorting or filtering data, such as classifying product images into specific departments or identifying the dominant scene in a photograph. Next is create an image classification job, multi-label. So this task allows an image to be associated with one or more categories simultaneously. It is used when an image contains multiple distinct concepts or objects that are not mutually exclusive. So here workers are shown an image and a list of checkboxes. They can select all labels that apply to the image. For example, in a photo of a street scene, a worker might select car, person and building. This is crucial for complex datasets where images are rich in content and cannot be described by a single tag. And lastly, there is the image label verification type. So this is a quality assurance task type designed to validate the accuracy of labels generated by previous jobs, either by humans or automated models. It ensures high quality training data by adding a review layer. So here workers are shown an image along with the existing labels such as bounding boxes or segmentation masks that were previously applied. They are asked to judge whether the annotation is correct or incorrect, and they may be given the option to adjust or fix the label if it is wrong. This workflow is often used to audit the performance of a labeling workforce or to verify low confidence predictions from an automated labeling model. And that's all. Thanks for watching.